Good afternoon, all of you. In this class, we are going to discuss about the next concept, that is electrochemical cell and gives free energy of the reaction. Electrochemical cell and gives free energy of the reaction. In last class, we have discussed about the Nernst equation and we have solved a few numericals on that one. Nernst equation and the numericals also over. Next concept today we are discussing, that is electrochemical cell and gives free energy of the reaction. Means it is the relation between Gibbs free energy, that is delta G, change in Gibbs energy. Correct? That is called as Gibbs free energy and E cell of the reaction. That is, the concept is that it is the relation between Gibbs free energy and the E cell of the reaction. That is electrode potential of the reaction. That is called as what? Electrochemical cell. These two relations, that is the concept, electrochemical cell and Gibbs free energy of the reaction. Now, here, if you want to calculate the electrical work done in 1 second, electrical work done in 1 second, we have to use that formula. The formula is electrical work done. How much work done? Electrical work done in 1 second. In 1 second means in only 1 second, how much electrical work done is done over. That can be calculated by using the formula charge into electrode potential. Charge into electrode potential. Electrode potential means in only 1 second, how much electrical work done is over. That can be calculated by using the product of charge and the electrode potential. This will give the work done, electrical work done in 1 second. Now, electrochemical cell we are using. Which cell? Electrochemical cell. What is meant by electrochemical cell? The cell which converts chemical energy into the electrical energy is called as what? Electrochemical cell. Now, in the electrochemical cell, the best example is Daniel cell, or you can take galvanic cell. Right? Those are the best examples for the electrochemical cells. For that one, how much work done by that cell? How much work done by that cell can also be calculated by using same formula. That is work done by the galvanic cell. Work done by galvanic cell. Galvanic cell. Here I am taking electrochemical cell. Electrochemical cell are also called as what? Galvanic cell. Galvanic cell. Therefore, work done by the galvanic cell in 1 second. Again in 1 second can also be calculated by using the same formula, that is charge into the electrode potential. Charge into the electrode potential. Now, in the first PUC, we have studied two types of work. One is work done on the system. Work done on the system. For example, this one is the system. Is it correct? Now we are applying some external energy on the system. That is called as what? Work done on the system. Work done on the system. For example, this one is another system. Just in case this one is piston. Now, piston is moving upward. Right? Here external pressure, let us take it as PA, external pressure. Here it is P, internal pressure is there. Now just think that piston is moving upward, means work done by the system. Work done by the system. If the piston is moving downward, this is the total system. This one is the total system. Here piston is there. Here piston. Now I am taking outward pressure as P external. Correct? And this is the inward pressure, or you can say the system pressure. Systems pressure which is inside the system. Right? Now just think that if the piston is moving upward, It is moving upward. Right? It indicates that the system is doing work. That is system by the work done by the system. That is called as what? Work done by the system where the piston is moving upward. Now, if we apply the external pressure once again more, right? What happens? Piston moves downward. Piston moves downward. That is called as what? Work done on the system. External pressure we are applying on the system. Right? That is called as what? Work done on the system. Work done on the system. If the piston is moving upward, right, means indirectly P pressure inside the system is greater than the P external. Then only the piston moves upward. This is called as what? Work done by the system. Work done by the system. In case of work done by the system, we are taking here work done by the system. Just read here. It is work done by the system. By the system means what? The system's energy is decreasing. System is doing work means what? Its energy is decreasing. I can write here decrease in energy. Work done by the system. System is doing work means decrease in the free energy. Decrease in the free energy. It is decrease in the free energy of this cell is equal to same formula, charge into electrode potential. Charge into electrode potential. Why I am writing here decrease? Because it is the work done by the cell, by the system, by which the system's energy decreases. I am writing that is only decrease in the free energy is equal to charge into electrode potential. Here, decrease in the free energy can be written as minus delta G. Minus means decrease. Minus means what? Decrease. Decrease in the Gibbs free energy. Decrease in the Gibbs free energy is equal to charge. Charge here Faraday. F means what? Faraday. Faraday means it is the charge of 1 mole of electrons. It is the charge of what? 1 mole of electrons. Right? If 2 moles of electrons are there, 2 into F 2 Faraday. If 3 moles of electrons are there, 3 into F 3 moles of electrons charge. That is 3F. Correct? 1F means what? It is the charge on 1 mole of electrons. If in a chemical reaction, N moles of electrons are there, what will be the total charge? NF. 1 mole of electrons total charge is 1 Faraday. 2 mole of electrons total charge is 2 Faraday. Correct? If N moles of electrons are there in the chemical reaction, what will be the total charge? NF. Right? Means it is the total charge. Total charge. N is the number of moles. N is the number of moles. F means what? It is the Faraday's constant, or you can say it is the charge of 1 mole of electrons. Charge of 1 mole of electrons. Into same charge of next one is electrode potential. Electrode potential I writing symbolically, that is E cell. E cell means what? Electrode potential of the cell. Here, once again, if you take this negative sign this side, it will become delta G is equal to minus NF E cell minus NF E cell. This is the formula that we want to get here. This will give the relation between change in Gibbs energy and the E cell. That is electrode potential of the electrochemical cell and the Gibbs energy. Change in Gibbs energy. This relation we will get by this relation. Now here, it is for any cell. It is not for a standard cell. It is for any cell. If you are using standard cell in place of any cell means whatever may be the concentration. If you are using the standard cell where the concentration should be 1M, right? If you take the standard cell, then E cell will become inert cell. Standard means what? E cell become inert cell. Similarly, delta G becomes delta naught G. That is for standard cell. For standard cell, what happens? Delta will become delta G. That is for standard cell. Here this not indicates that the concentration of the cell is 1M, right? Is equal to same minus NF E naught of cell. Means when the standard cell is there, you have to use this formula. If the normal cell at any concentration, if you are calculating, then you have to use this formula. This is for standard cell. This is for any cell. Right? Where here where delta G means what? Change in Gibbs free energy. Delta change. G means Gibbs free energy. That is called as change in Gibbs. Change in Gibbs free energy. Free energy. N means what? Number of moles of electrons. Number of moles of electrons. If 1 mole of electron in the reaction is there, you have to take N is equal to 1. If 2 moles of electrons are there in the chemical reaction, you have to take N is equal to 2, etc. Right? Now, F means what? Faraday's constant. Faraday's constant. Its value is fixed. How much it is? 96,500 coulomb per mole. Coulomb per mole. That is the charge of 1 mole of electrons. Next, E cell means what? Cell potential. Cell potential. Here, just think that here delta G naught is there. It is standard change in Gibbs free energy. Delta E naught cell, standard cell potential. Standard cell potential or standard electrode potential. Clear? Here we are interested in only these two formula. These two formula will give the relation between the electrode potential and the Gibbs free energy. This formula will give what? Relation between the electrode potential and the Gibbs free energy. If the standard cell is there, just use this formula. Right? This will be the standard electrode potential and this will be the standard change in standard Gibbs free energy. Here, one more important point is that we know here delta G means change in Gibbs energy, E cell means electrode potential, right? Delta G here, change in Gibbs energy, E cell, that is what? Electrode potential. Here delta G is extensive property. Delta G means what? Change in Gibbs energy. It is which property? It is extensive property. Extensive property. E cell is intensive property. Which property it is? Intensive property. Here delta G extensive property, E cell intensive property. What is meant by extensive property? What is meant by intensive property? We have already studied in the first PUC in thermodynamics chapter. Which chapter? Thermodynamics. Now, once again, I will tell what is meant by extensive properties. The properties which depends upon the amount of matter. The properties which depends upon the amount of matter. For example, this one is one of the beaker. One of the beaker having this much of water. Just think this much of water, and this one is same beaker having this much of water. The mass of these two beakers is same or different? The mass tension different. Here small amount of water is there. Right? Here large amount of water is there. If it is now having mass m1, it is having mass m2, where mass m2 is greater than m1. Right? Means mass is depending on amount of matter. Amount of matter. As the matter increases, as the water increases, the mass is also increasing. Mass is also increasing. Such type of properties are called as what? Extensive properties. Extensive properties. Example: mass, volume, etc. It depends upon the amount of matter. Clear? Now next, for both beaker, if you want to calculate the boiling point of this water and also the boiling point of this water, you will get same answer, same boiling point. Means the property which does not depends upon the amount of matter. Here boiling point, small amount of water is there. If you calculate the boiling point of that water, you will get, for example, 100 degrees Celsius. Here large amount of water is there. Large quantity of water is there. If you calculate the boiling point of that water also, you will get the 100 degrees Celsius only. Means it is not depending on the amount of matter. Boiling point is not depending on the amount of matter. Such type of properties are called as what? Intensive properties. Intensive properties. The properties which depends upon the amount of matter are called as what? Extensive properties. The properties which does not depend upon the amount of matter are called as what? Intensive properties. Means delta G depend upon the amount of matter. Here E cell is not depending on the amount of matter. Now, we will take one example also. One example. Let us take one example. For Daniel cell, we know overall reaction. Example. I am taking two reactions. For both Daniel cell only. Overall reaction for the Daniel cell is Zn plus Cu plus 2 gives rise to Zn plus 2 plus C. Here it is solid. Here it is aqueous solid. Now this is the overall reaction of the Daniel cell. Now I want to multiply 2 here. I want to multiply 2 to this reaction. It will become 2 into Zn. I am multiplying 2 to the overall reaction. It will become 2 into Zn. Again it is solid plus 2 into Cu plus 2. Right? Again it is aqueous. Here it is 2 into Zn plus 2. That is aqueous plus 2 into Cu. That is again solid. I have multiplied how much? 2. Right? Here only 1 is there. Right? Here coefficients are 2 are there. Now just think here how many electrons are involved in the reaction. How many electrons are involved in the reaction? Just to calculate. Here Zn is there, here Zn plus 2 is there. Means Zn is converting into Zn plus 2. Means how many electrons are lost? 2 electrons. How many electrons are lost? 2 electrons. Here Zn oxidation state 0. Here oxidation state of Zn is plus 2. How many electron difference is there? 2 electrons. After losing 2 electrons, it will become Zn plus 2. Those 2 electrons, here Cu plus 2 is there, here Cu is there. Cu plus 2, Cu. Here oxidation state 0. 2, 0. How much difference is there? 2. Those 2 electrons are gained by the Cu. Take anyone, take Zn or Cu for calculating the number of moles of electrons involved in the reaction. If you want to calculate how many number of moles of electron involved in the chemical reaction, select any metal. Here I am taking zinc. Here 0 oxidation state, here 2 oxidation state. Zn to Zn plus 2. When it will happen? After losing 2 moles of electrons. That is here n is equal to how much? 2. Now take the difference between the charges. Here how much? What is the charge? Plus 2. Here what is the charge? 0. What is the difference? 2. Therefore how many moles of electrons are involved? 2 moles. That is n is equal to 2. Just check here. Here total charge is 0. Here total charge is plus 2. Again how many moles of electrons are involved? Just take here 2 Zn are there. 2 into 0. The total charge is 0. Here 2 into plus 2. 2 into plus 2 means what is the total charge? Plus 4. 1 Zn charge is plus 2. 2 Zn charge is plus 4. Correct? Here 4 is there, here 0 is there. Means how many moles of electrons? 4 moles of electrons are involved in the reaction. That is here n is equal to 4. N is equal to 4. Right? This one is I am calling reaction 1. This one I am calling as reaction 2. I took 2 reactions for the same reaction, for the same cell. That is Daniel cell. Right? Now here n is equal to 2. Here n is equal to 4. If you check the E cell value, very important point. E cell for the first reaction and second reaction will be same. E cell for the first and second reaction. E cell for first and second reaction will be same. Because E cell of the first reaction is equal to the E cell of the second reaction. Both are having same E cell value, That is exactly equal to the already we have calculated how much it is 1.1 volt. 1.1 volt. Correct? For standard cell I am taking it is equal to how much 1.1 volt. 1.1 volt. For the first reaction, if you check the E cell value, it will be how much 1.1 volt. For the second reaction, if you check the E cell value, it will again how much 1.1 volt. Now, what about the delta G for the first reaction and delta G? Here I am taking not because I am taking standard cell. Now here delta G now is equal to how much? If you check delta G for the first reaction, delta G for the second reaction, it will be different. That is, change in Gibbs energy for the first reaction is totally different from the change in Gibbs energy for the second reaction because n value is changing. Delta G value depends upon the n value. As the n value changes, delta G also changes. Here n is equal to 2 is there. Here n is equal to 4 is there. Therefore, delta G naught for the first reaction is totally different from the delta G naught for the second reaction. Means it is depends upon the amount of matter. I have doubled the amount, just multiplied by 2 means I have doubled the amount. As the amount of matter changes, here delta G is changing. Amount of matter is changing. Here 1 is there. Here I have doubled the amount of matter. Now here 1, here 2 is there. Amount of matter is changing. As the amount of matter or amount of substance changes, what happens here? Delta G is changing. Where E cell is same. Therefore, only I am writing delta G is extensive property. It depends upon amount of matter. Whereas E cell is intensive property. That does not depend upon the amount of matter. Clear? Now, delta G extensive property, E cell intensive property. We derived the equation that is delta G is equal to minus NF EZ. Or for standard cell, what will be the equation? For standard cell, or for standard cell, I can write for standard cell. For standard cell, delta G naught is equal to, it will be minus NF E naught of cell, where N is number of moles of electrons involved in the reaction. That means Faraday's constant, that is 96,500, or it is charge of 1 mole of electrons. E naught cell means standard electrode potential. What is the use of these two reactions? That is also question. What is the use of these two reactions? Now, what is the significance? We are seeing what? Next, significance of this equation. Significance of this equation. Now, just check. We know that if the delta G is negative, then the reaction is feasible. We have studied. Then the reaction is feasible or spontaneous. If delta G is negative, then that reaction is feasible or it is spontaneous. If delta G is positive, then the reaction is not feasible or it is non-spontaneous. Not feasible or non-spontaneous. Negative, it is feasible and spontaneous. The reaction is feasible and spontaneous. If the delta G is positive, then the reaction is not feasible and it is non-spontaneous. It is not feasible and it is non-spontaneous. Clear? Now what happens when delta G is equal to 0? The reaction is at equilibrium. That is called as what? The reaction is at equilibrium. Clear? Now just given delta G is equal to negative, then the reaction is feasible and spontaneous. If the delta G is positive, then the reaction is not feasible and it is non-spontaneous. If delta G is equal to 0, then the reaction is at equilibrium condition. That is rate of forward reaction is equal to rate of backward reaction. Clear? Already these things we have studied in the first PUC in thermodynamics, right? Now, significance we will see. It helps to predict which reaction is feasible, which reaction is not feasible. Means what? For a given reaction, that reaction is feasible or not. That will be calculated by using these equations. Right? Now, here first I am taking here if delta G is negative. When delta G is negative, I want delta G should be negative. When it is possible, E cell should be positive or negative. I want total answer in terms of negative. Right? It is possible only when E cell should be positive. E cell should be positive. If E cell value is negative, negative into negative will become positive. But we want delta G negative. Delta G negative. It is possible only when E cell is equal to positive. E cell is equal to positive. Here negative is there. This value positive. This value positive. This value is also positive. Right? Therefore, positive into negative is again negative. Means delta G is negative only when E cell is positive. Means in this condition, when delta G is negative and E cell is positive, the reaction is feasible. The reaction is feasible and it is spontaneous. The reaction is feasible and it is spontaneous. Now, what happens when delta G is equal to positive? I am taking delta G is equal to positive. When it is possible, E cell is negative or positive? Here it is, negative is there. Right? Now, I want total answer in terms of positive. Means E cell should be negative or positive or negative. Negative into negative is positive. Therefore, it is possible only when E cell is equal to negative. E cell is equal to negative. When E cell is negative, delta G is positive. Delta G is positive means the reaction is feasible or it is not feasible. The reaction is not feasible. The reaction is not feasible. Is not feasible. Right. Now last one. delta G is equal to 0. When it is possible, E cell should be equal to how much? 0. I want delta G, total value should be 0. When it is possible, E cell should be equal to 0. 0 into F, 0 into N is again 0. That is, E cell is equal to 0. Now, in this condition, when delta G is equal to 0, that is called as the reaction is at equilibrium. The reaction is at equilibrium. Here, delta G is negative only when E cell is positive. Delta G is positive only when E cell is negative. Just observe this reaction. Delta G is negative only when E cell should be positive. Delta G is positive only when E cell should be negative. Delta G is equal to 0 only when E cell is 0. Right? This is the conditions. If chemical reaction is given, one of the chemical reaction is given, and he is giving E cell is equal to some positive value, then he is asking the reaction is feasible or not. Your answer should be E cell is equal to positive, means the reaction is feasible. If he is giving one of the chemical reaction and he is giving its E cell value and it is negative, for example, let us take few example. Question number 1. E cell for the given reaction is minus 0.232 volts. Now 4 options are there. The reaction is feasible, the reaction is not feasible, the reaction is at equilibrium. Now which one is correct answer? Or last, none of the above. Which one is correct? E cell is negative. E cell is negative. Here E cell is negative. Here it is. E cell is negative. The reaction is feasible or not feasible? It is not feasible. Means second option is correct. Because E cell is negative means delta G is positive. Here question is delta G is equal to minus NF E cell. Minus NF E cell. Right? N is fixed for a reaction. F is fixed for a reaction. Right? Both are constant. Here it depends upon E cell. Here E cell is negative. Negative into negative is positive. Means we are getting delta G positive value. Delta G is positive means the reaction is not feasible. The reaction is not feasible. If it is positive, which answer is correct? A option. Because here positive into negative is once again it is negative. Then the correct option is feasible. Clear? Now, when E cell is positive, the reaction is feasible. When E cell is negative, the reaction is not feasible. These points are very important for solving the NEET or JEE questions. These things are very important while solving which concept? Which questions? NEET or JEE. Just remember, E cell is positive, the reaction is feasible. E cell is negative, the reaction is not feasible. Now, we will solve a few numericals on the same formula. What is the formula? What is the formula? Delta G is equal to minus NF E cell. It is for any cell, whatever may be the concentration, right? Then you have to take this condition. If the concentration is 1 that is standard cell, delta G naught is equal to minus NF E naught option. Minus NF or E naught option. Before that, I want to derive another relation. That is the relation between Gibbs free energy and the equilibrium constant. I want to derive another relation. That relation between the Gibbs free energy and the equilibrium constant. And I note here. I am using same reaction. Delta G naught is equal to minus NF E naught of cell. I want to derive relation between Gibbs free energy and the equilibrium constant. Means this reaction, just assume that this reaction is at that chemical reaction is at equilibrium. Right? Now already we have seen at equilibrium E naught of cell is equal to, in the last equation we have derived this formula. Right? Now at equilibrium E naught of cell is equal to 0.0591 L log Kc. Kc is what? Equilibrium constant. Kc is called as a equilibrium constant. Here at equilibrium E naught of cell is equal to 0.0591 by N log Kc. Now we are getting 0.0591 when? By solving the things, by solving the or substituting all the constant, means we are getting 0.0591 when it is multiplied with the 2.30T RT by this NCl EF. If you simplify this 2.303 into R value, that is 8.314 into standard temperature, 298 Kelvin, and Faraday's constant, that is 96,500. After simplification, you will get the 0.0591. In place of 0.0591, I am writing all the constants. That is 2.303 RT by NF into log Kc. Log Kc means in place of E naught of cell, I can write this. Means here in place of E naught cell, I am writing this. That will be now delta G naught is equal to whatever minus NF as it is. In place of E naught cell, what is the thing say? 2.303 RT by NF log Kc. Correct? Here NF, here also NF. Both will get cancelled. What is that? Delta G naught is equal to minus 2.303 RT log Kc. Log Kc. If you don't want to write 2.303, in place of log, just write lambda. Right? No. This formula is also very important while solving mean or JW questions. If he is giving equilibrium constant, if he is giving what? Equilibrium constant, and he is asking Gibbs free energy, just use this formula. That is delta G naught is equal to minus 2.303 RT log Kc. Now, otherwise, if he is giving standard Gibbs energy change and he is asking equilibrium constant, then you have to use the same formula. That is delta G naught is equal to minus 2.303 RT log Kc. Now, that formula also I want to write here for solving the two numericals. Delta G naught is equal to minus 2.303 RT into log Kc, where Kc is called what? Equilibrium constant. This Kc means what? Equilibrium constant. Here, where Kc, it is equilibrium constant. Equilibrium constant. R universal gas constant. Its value is, here I am taking 8.31. Next, T temperature. It has standard temperature of just temperature in terms of Kelvin. Clear? Now we will solve few numericals on same formula. Here. Just remember those three formulas. Delta G is equal to minus NF. E cell, N means what? Number of moles of electrons involved in the chemical reaction. F means what? Faraday's constant, or it is the charge of 1 mole of electrons. 1 mole means 6.02 into 10 to the power 23 electrons charge. That is Faraday's constant. That will be 96,500. Right? E cell means electrode potential. Right? Now here Kc means equilibrium constant, R means universal gas constant, T means temperature in Kelvin. Right? We will solve numericals. Only two numericals are there. Now first one, add on the numerical. First numerical. The standard electrode potential for Daniel cell is 1.1 volt. Calculate the Gibbs energy for the reaction. Calculate the Gibbs energy for the reaction. Gibbs energy for the Daniel cell, that is reaction is 7 plus C plus 2 yes U by 7 plus 2 yes plus C is the question. Solution. Okay, what is asking? The standard electrode potential for the Daniel cell is 1.1 volt. He is not giving only cell potential. He is giving what? Standard. Correct? Here standard electrode potential. Standard electrode potential means it will be E naught of cell is equal to, I am writing given data, given E naught of cell, that is standard electrode potential for the which cell? Daniel cell is how much? 1.1 volt. Means standard electrode potential E naught of cell is equal to 1.1 volt, already given. What he's asking, calculate the Gibbs energy for the reaction. Means he's asking delta G is equal to how much? Gibbs energy for the reaction, right? Means here standard given means you have to take standard Gibbs energy. Standard change in standard Gibbs energy for the reaction is equal to how much, right? But we know that formula, we know that here delta G in our substance. Which reaction is that? Which formula we have to use for calculating delta G naught from the E naught of cell? The second formula here. Delta G naught is equal to minus NF into E naught of cell. This formula we have to use to calculating the delta G naught value. We know that this formula delta G naught is equal to minus NF E naught of cell. Now just check. F value is fixed. How much it is? 96,500 coulomb per mole. Coulomb is the unit of charge. It is for 1 mole. Therefore, I am taking per mole. Next, E naught of cell it is given. How much it is? 1.1 volt. But N value is not given. How to calculate? Clear? N value is not given. How to calculate? Already I told you. Select reaction is given. Reaction is given. Select any one metal. I am selecting zinc. I am selecting zinc. Here charge is +2. Here charge is 0. What is the difference? 2. What is the difference? 2. Means how many number of moles are electrons are involved in? 2. N is equal to how much? 2. Or select copper. Here +2 is there. Here 0 is there. How much difference? 2. Right? That is 2 moles of electrons are involved in the chemical reaction. What is F value? Faraday constant. It is fixed. 96,500 coulomb per mole. Coulomb. Now substitute N value, substitute F value, substitute E naught value. You will get easily delta G naught value. Change in Gibbs energy for the reaction. Now I am substituting all the values. Therefore, delta G naught is equal to N value is how much? 2 minus as it is. The N value is 2 into F value is how much? 96,500 into here E naught of cell value is how much? 1.1 volt. If you multiply all the things, you will get how much? You will get the answer. That is equal to minus 213,212,300 joule per mole. You will get this much of value. How much? 212,300 joule per mole. I want to write in terms of kilojoule. Kilo is equal to how much? 10 to the power plus 3 should be there. If you want to write kilo, 10 to the power plus 3 should be there. When you will get the 10 to the power plus 3? When the decimal shift towards the left side. That we have already discussed in the first PUC. What happens when the decimal shifted towards the left side? What happens when the decimal shifted towards the right side, etc. Right? When the decimal shifted towards the left side, it will be 10 to the power plus. When the decimal shifted towards the right side, it will be 10 to the power minus. It will be 10 to the power plus. It will be 10 to the power minus. If only one digit you are shifting, that will be 10 to the power plus 1. Towards left side, you are shifting 2 digits. It will be 10 to the power plus 2. Towards right side, if you are shifting decimal only one digit, then it will be 10 to the power minus 1. If you are shifting 2 digits, it will be 10 to the power minus 2, etc. Right? Now here, where the decimal point is there, here it is. Correct? Now I want to write 10 to the power plus 3. Means I have to shift decimal towards the left side. Plus 3 I want. Therefore, decimal shifted towards the left side. For how many digits? 3 digits. Therefore, it will be 1, 2, 3. Right? Therefore, it will be minus 212.300 kilojoule per mole. This is the delta G naught value for the Daniel cell. In some competitive exams like NEET, he will ask, calculate the delta G value or delta G naught value or change in Gibbs energy value for the Daniel cell. He will ask only this much. Calculate the change in Gibbs free energy value for the Daniel cell. He won't give any data. Then you should have to remember for the Daniel cell, E naught cell value is fixed. How much it is? 1.1 volt for Daniel cell. Just remember, for Daniel cell, E naught cell value is fixed. How much it is? 1.1 volt. N value is fixed. How much it is? 2. Faraday's value already know how much it is? 96,500 coulomb per mole. By substituting all the data for the Daniel cell, you can calculate the delta G naught value. That is should be equal to how much? Minus 212.300 kilojoule per mole. Clear? In place of giving all the data, just he will ask calculate the gives free energy for the Daniel cell reaction. Right? Daniel cell means inert cell value is fixed. How much it is? 1.1 volt. N value is fixed. How much it is? 2. Right? F value already you know how much? 96,500. Put all the values in this formula, you will get the same answer. Next. Second one. Second one. The cell in which the following reaction occurs. The cell in which the following reaction occurs. Now cell reaction is here I am writing 2 Fe plus 3 aqueous plus 2I minus aqueous gives rise to 2 Fe plus aqueous plus I2 solid. Here it is I2 solid has E naught of cell is equal to 0.236 volt at 298 Kelvin. At 298 Kelvin temperature, calculate the standard Gibbs energy. Calculate the standard Gibbs energy. And the equilibrium constant of this reaction. And the equilibrium constant for the cell reaction. For the cell reaction. Solution. Just try to understand the question properly. Right? What he is asking. In the cell in which the following reaction is taking place. The cell is there in which this reaction is taking place. Already he given the reaction, that is 2Fe plus 3 plus 2I minus gives rise to 2Fe plus 2 plus I2. This one is the redox reaction taking place in the cell, and he is giving its inert cell is given. For example, this one is the one of the cell, right? Here it is voltmeter cell reaction. Its inert of cell is equal to how much? Given. Inert of cell is equal to how much? 0.236. 0.236 volt. Inert cell value is given. And temperature is also given. What is the temperature? T is equal to how much it is? 298 Kelvin. Temperature is also given. Inert of cell value is given and temperature is given. What he is asking? Calculate the standard Gibbs energy. Standard Gibbs energy means delta G naught is equal to 1. And also is asking calculate the equilibrium constant for the reaction. Equilibrium constant, that is Kc for the reaction. Here is asking two data. Calculate standard Gibbs energy and also calculate the equilibrium constant. Equilibrium constant. For calculating delta G naught, which formula you have to use? Second formula. Delta G naught is equal to minus NF into inert of cell. Inert of cell is already given. That is 0.236, right? Now, F value already we know how much it is. 96,500 coulomb per mole. That is charge of 1 mole of electron. N value we can calculate by seeing the reaction. By observing the reaction, we can calculate how many electrons are involved in the reaction. Means N is known, F is known, inert of cell value is also known. Then easily we can calculate the delta G naught. Delta G naught by using that formula. After getting delta G naught, we want to calculate Kc. That is equilibrium constant. Delta G naught we have already calculated. Just substitute that value here, right? And minus 2.3. R value is fixed. How much for the gas? 8.314. Just substitute here. Temperature is given. Just check. What is the temperature here? 298 Kelvin. Just substitute here temperature. And after that, we will easily calculate the Kc. But after taking log other side, it will become anti-log, right? By substituting those all the values, after taking log to the other side, we can easily calculate the KCL. By using these data first calculate delta G naught. By using the delta G naught, we can easily calculate the KCL. Now we will solve it. Now, here, given data. I am writing given data. What are the given data? The cell in the following reaction is taking place. This reaction. For that one, E naught of cell is given. E naught of cell is equal to how much? How much it is? 0.236. It is positive or negative? Positive. The reaction is feasible or not? Feasible. E naught of cell positive means delta G is negative. Opposite. It is positive, that is negative. The reaction is physical. Means this reaction can take place. Right? Next, at the temperature. What is the temperature? 298 Kelvin. This one is the temperature. What is asking? Calculate standard Gibbs energy. That is delta G naught is equal to how much as well as equilibrium constant. And Kc is equal to how much? Clear? Now, here for calculating delta G naught, we require n value. How to calculate n value? Again, question is there. Select any one. Either select Fe or iodine. Either select Fe or iodine. I am selecting Fe. Right? Here it is. How many Fe are there in the reactor? 2 Fe plus 3. How many ions of Fe plus 3 in the reactant? 2. 2 Fe plus 3 in the reactant. In the product, how many Fe plus 2 ions are there? 2. 2 Fe plus 2. Here, 2 Fe plus 3 in the reactant, 2 Fe plus 2 in the product. Same I am writing. Only one I am selecting. Right? Now, what will be the total charge? 2. 1 Fe charge is plus 3. Here, how many Fe are there? 2 Fe. 2x can be written as x plus xn. 2 similarly 2 Fe plus 3 can be written as Fe plus 3 plus Fe plus 3 means what is the total charge? Plus 6. 1 Fe has charge plus 3. 2 Fe charge is plus 6. Right? Here it is plus 6. Use rise to 1 Fe charge is plus 2. But how many Fe are there? 2 Fe. What will be the total charge? Plus 4. Correct? Here it is plus 4. What is the difference? Plus 6 and plus 4. What is the difference? 2. Means number of moles of electrons involved are 2. N is equal to 2. Or select this one. 2 into minus 1. Minus 2. 2 into minus 1 is minus 2. Here charge is 0. Minus 2, 0. 0 minus 2 is 2. 2 moles of electrons are involved in the reaction. It may be minus or plus. Just think that 2 electrons are involved. Right? Now here how many moles of electrons are involved? 2. N is equal to 2. We can calculate by using this one. Next. Faraday's constant, how much it is? F is equal to 96,500 coulomb per mole. Clear? First, we are going to calculate the delta G naught value. Right? How to calculate? Already we know delta G naught is equal to which formula? Second formula minus NF E naught of cell. Right? Now substitute all the values. N value is how much? 2. E naught value is 0.236. Right? F value is 96,500. Substitute all the values. N value is 2. F value is 96,500. P naught of value is how much? 0.236. Multiply all these data. 2 into 96,500 into 0.236. It will be minus 45548 joule per mole. Energy measured in terms of joules, but per mole it is joule per mole. This is the delta G naught value. But he is asking again. What he is asking? Equilibrium constant also he is asking. Therefore, you have to use this formula. Right? Again, we know that. Just observe carefully. We know that delta G naught is equal to minus 2.303 RT log Kc. Right? Delta G naught value now only we have calculated. Just substitute this value. It will be how much? 4, 5 minus. Correct? 45548. Right? 45548 is equal to minus 2.303. R value, universal gas constant, how much it is? 8.314. 8.314 into temperature is your how much it is? 298 K 298 into log Kc as it is. Log Kc as it is. Now here minus I can cancel both sides. Minus cancel each other. Right. Next, what will be there? Here 45548 divided by 2.303 into 8.314 into 298. I'm taking all these terms this side. Theta numerator will become the denominator because here the relation between these all is multiplication is there. Correct? Into will become divide other side. Therefore, it will be is equal to log Kc. Log Kc. I could call that data. Just check 2.303, 2.303, 8.314, 8.314, 298, 298. Log Kc. Data. Substitute all the values and just to simplify this one, you will get here. I am writing log Kc this one. You will get 7.981. Just after simplification, you will get 7.981. It is positive. It is positive. Negative cancelled each other. Negative cancelled each other. Right? Therefore, it will be positive. Why I am telling positive? Because reason is there. Right? Here Kc is there. Log Kc. If you take log that side, it will become anti-log. Log will become anti-log. Therefore, it will be Kc is equal to what? Anti-log of how much? 7.981. 7.981. Anti-log of positive value is different. Anti-log of negative value is also different. Checking process is also different. If you are having log book, if you want to calculate this, or if you want to see the anti-log of 7.981 positive value, it is totally different from the anti-log of negative 7.981. Total process is different. That's why I'm taking that. Here it is positive. I'm telling what? Here it is positive anti-log. Positive anti-log. How to check the positive value anti-log? Just check. Anti-log of positive value. How to check is whatever may be the value before the decimal, it will become 10 to the power. It will become what? 10 to the power. Here before decimal, what is there? 7 is there. What is there? 7. It will become 10 to the power plus 7. 10 to the power plus 7. After taking this one, what is left? Is 0. Means what is left here? 0.981. 0.981. In anti-log, just check 0.981. That is 0.9. Just check here, and 1 is there. Just check. You will get the answer. 0.98. You have to search here somewhere else. 1 is here. In that one, you have to select that value. That will be equal to how much? 9.57. 9.57. First two digits you have to search here. You will get 0.98 somewhere else in anti-log. After that 1. Here 0 is the 1. In 1. Just check that value. It will be 9.57. This is equilibrium constant. Now, once again, today what we have discussed about the Gibbs free energy and the electrochemical cell. Gibbs free energy and electrochemical cell. First, we have derived the relation between Gibbs free energy and the electrochemical cell. That equation, that is delta G is equal to minus NF E cell value. For that one, work done is required. Work done, electrical work done in 1 second can be calculated by using the formula charge into electrode potential. Work done on the system. Work done on the system is different from the work done by the system. Work done on the system, that is increase in energy. System's energy increases. Work done by the system. System is doing work. Then decrease in the energy. Decrease in the energy. I am taking minus delta G. Minus delta G. Charge 1 mole means 1F. 2 moles means 2F. N mole means NF. Electrode potential I am taking E cell. Then we have derived this formula. Delta G is equal to minus NF E cell. For standard cell, it will become delta G naught is equal to minus NF E naught of cell. After substituting E naught of cell, I will get the relation between delta G and equilibrium constant. After substituting this E naught of cell value, that is 2.303 RT by NF into log Kc. If you substitute this value, NF get cancelled. That one is delta G naught is equal to minus 2.303 RT log Kc. Right? Now, here he may ask delta G value by giving E cell value, or he may ask E cell value by giving delta G value. Right? Now, by using this formula, you can calculate the delta G value. Just remember, only when the reaction is feasible, only when E cell is positive. E cell is positive. The reaction is not feasible only when E cell is negative. E cell is positive means here positive is there, here negative is there. Negative into positive is negative. Delta G you will get negative. Then the reaction is feasible. If E cell is negative, negative into negative, what happens? Positive. Delta G is positive. Then the reaction is not feasible. It is not feasible. When delta G is equal to 0 means it is an equilibrium. Okay. Now today we will stop here only. We will continue in the next class.